Hello everyone, welcome to this class. We're going to work on a cool project which is called an RGB LED. What is an RGB LED? An RGB LED is simply an LED that can display varieties of colors. So using RGB LED, you don't need to buy your red LED, yellow LED, green LED, or whatever color of LED. You just use one LED to display any amount of color you just want to use in your project. So we'll be working with RGB LEDs to display whatever color of LED by just simply identifying the pin numbers which it's connected to and the color intensity we want to use. So open our Tinkercad platform. Right here you see 3D designs and 3D circuits. You just go to circuits, and then at the top here you just see create new designs. You click create new designs to open up your basic platform and your workspace. So as usual, you look for your Arduino Uno R3, you drag that into your workspace, and then you drag in your breadboard small. Breadboard small. Okay, so now we'll look for a component called RGB LED. So you simply scroll to the top. Okay, let's look for RGB. Okay, so you see LED RGB. So you just drag that component into your workspace. So I'm going to explain a bit. So if you look closely, this is an RGB LED. It has 4 pins, so it's not like any normal LED. It has red, it has a cathode, blue, and green. So an RGB LED just mixes these 3 primary colors, red, blue, and green, and then with the mixture of these colors with different intensity, you can create wherever colors you want: magenta, yellow, brown, black, white, whatever. So with the mixture of all these primary colors, you can get whatever color. So you can just identify these mixtures by using color intensity. So you can just put in the intensity of color you want to use from 0 to 255. 0 being the lowest intensity and 255 being the highest intensity. Now jump into our code, you understand what we're working with more better. Okay, so we come back into our workspace. So we drag our RGB LED and position it on the breadboard. So put it on J1, 2, 3, and 4 respectively. Okay, so now you see that there are four pins. The 3 pins supposed to be connected to the PWM pin on the Arduino board. But before we do that, we have to drag out our resistor. So you drag the resistor, you change the resistance to 220 ohms. So instead of rotating it this time around, because there's no more space in between the LEDs, we'll just be working with it on a 90-degree angle. So we'll be connecting it into 2. So drag out the resistor. We'll put it, the first terminal will be on an empty hole on the same column for the red pin on the RGB LED. So make sure there's a resistor there, and then the other terminals will be connected to the other side of the breadboard, which is from E to A. So you have the resistor breaking the connection point from the first side of the breadboard to the second side of the breadboard. So it's still going to work as far as the resistor is connected to the other side. Now we drag our wire from the other terminal of the resistor we put a wire on any, we click inside any of the empty holes which is connected on terminal 1 of the resistor. Then we drag out the wire and connect it to a PWM pin. So a PWM pin is simply a pin that has a tilde or a dash beside it. Just it's on pin 3, pin 5, pin 6, pin 9, pin 10, pin 11. So these are the pins that have PWM pins. So the PWM pins has a variations. It doesn't just come on and go off. It can reduce or increase a particular amount of resistance of that pin. So that's the particular purpose you need this for, because when you're working with intensity, you have to put in the intensity from 0 to 255, and that's the right amount of variables or the right amount of intensity the PWM pin offers. So drag a wire to a PWM pin, we change it to red. Okay, so the next one here is the cathode, and the cathode, as you know it, is for your ground or your GND. So we only have the empty holes which is connected to that cathode. So there's no need to go over to this other side because there's nothing connecting this side to this side. There's no resistor that's breaking in the connection from the other side to this side of the breadboard. So we'll just be using just this first part. So to the cathode, any of the empty holes, you click inside any of the empty holes, drag out your wire. Okay, so drag it out here, and then connect it to GND. So our GND is always black, which stands for negative. Now we take another resistor to connect our blue and green pins of the RGB respectively. Now we change the resistance to 220 ohms. We check that and position it on the first terminal. The first terminal goes to the first part of the breadboard, and the second terminal goes to the other side of the breadboard. So we'll click on any of the empty holes connected to the first terminal of the resistor. Make sure it's connected on the same column with that terminal. Then drag out the wire and then connect it to digital pin 5. Change the color to red. Okay, this is for the blue pin. And then lastly, for the green, we drag out another resistor, change the resistance to 220 ohms. Okay, so we drag another wire, make sure it's on an empty hole on the same column with that terminal. So make sure it's on that particular terminal. So do well not to make much mistakes. Make any mistakes, it's okay. Just look at the schematics for the project and look at your project to correct your connections. So most of the times you don't really know your connections is wrong. When you're done, you're coding, you're done wiring, that's when you now discover that, oh, my project isn't working properly. So that's where you have to start cross-checking and cross-checking and cross-checking. So it might take some time, but you have to get used to it. Nobody's above mistakes. Okay, so that's all for the wiring part of our RGB LED. We are done with the wiring for this project. Now let's move into the coding. We will be writing our codes in C and C++. So let's dive in. So at the top corner, you click on code. Okay, so wipe out whatever was inside our void setup and void loop. So as usual, we start by creating a variable for each of the pins. So we say int, then we'll put in the pin the variable name, so red pin. We assign a value to it. So red pin is connected to pin 3. Then we say create another variable int for the blue pin. Let's see. For the blue pin, so blue pin, we assign a value to it, which is the pin number. So it's connected to pin number 5. So pin 5, we close the statement with a semicolon. All right, then int the last one being the green, so green pin. So note that we're using camel case, so we're capitalizing the initial letter for the second word. So the last one you're giving it a value of 6 because the green pin is connected to 6 on the Arduino. Okay, that's all the variables needed to be created. Now let's move into the voice setup and then tell the Arduino what state of the variable you're working with. So you just put in pin mode, you use the function pin mode to declare the state of the LED. So we call the LED by writing the variable name. So the red pin is an output pin. And then do the same for the blue and the green pin. Make sure you type those syntax correctly. And don't forget to end your statement with a semicolon. Make sure your variable names are correct. Okay, so that's all for the voice setup. You called in the built-in function pin mode and then put in the variable name which has the value of the pin number. So red pin has the value pin of 3 and then we selected the state of the pin to be an output pin. So this same thing for blue pin, which is pin 5, and the state of the pin is an output pin. And lastly, for the green pin, which is on pin 6, the state of the pin is an output pin. And make sure the output is all on capital letter. That is a keyword. Okay, now inside the void loop, we won't do much inside the void loop. We have to create a function first. You use the void keyword and type the function name. Sorry. So function name, which is RGB. So here we'll be using an underscore just to differentiate. You can use an underscore or you can use camel case. So we use an underscore because the first word I used they were all capital letters. So I use an underscore to differentiate the next word. So RGB color. So I want this to be all small letters. Next, we open a bracket and close the bracket. Then inside the brackets, we'll type in the parameters that our functions are going to need. So these functions will need three parameters. So it will need the value of the red pin, the value of the blue pin, and the value of the green pin. Value being the color intensity. So if I want the intensity to be 000, I can just put all zeros there. So that parameter just simply stores the value of the intensity needed. So to do that, I have to create a variable inside the box, inside the bracket. So the first one is an int variable, and the variable name will be red value. So that's camel case. Use a comma to differentiate it. The next one also is int, and it's blue. Sorry, blue value. And the last one is int green value. Okay, so you open a curly brace and then close the curly brace. So we've been using semicolons to close our statements. But this is a function. We don't want to close the statement entirely. We just want to create the opening for the function and then writing whatever instructions we want to give inside the curly brace. So open and close the curly brace, and then we separate the curly brace by pressing enter when you enter into it. So we can type whatever code we want inside those two curly braces. So anything outside the curly brace is not work when you call the function. But whenever you call the function, everything inside the curly brace is going to run. So now the instructions will be given our function. We'll be calling a built-in function here called analog write. So we use analog, you have to spell it correctly, analog write. So note the camel case. Analog, which is the first word, is on small letter, and then the initial letter after analog is W, which is capitalized. So you put that analog write, open and close your bracket, and end it to semicolon. So inside the built-in function, this function takes in two parameters. One being the pin number, and the second being the intensity of color needed. So we have three pin numbers. That means we have to create three different analog write function. So the first one, we're just calling the variable. So there's no need for us to be typing in the number of pin we used or the pin number. We just put in red pin because we've already created a variable, put a comma, and then since we have not yet given it any value, we just use the variable we created inside the RGB brackets we used. So we receive red value. So let me quickly explain. The reason why our analog write is like this is because when you type in the analog write value, you just simply supposed to type numbers. The first one being the number responsible for the pin, and the second one being the number responsible for the color intensity value. Okay, so since we just want to make it a lot more easier, since we're creating a function inside a function. Okay, so that's why we will need to call the value given from this function. So I'm going to explain better when we're already wrapping up, when we finish the code. So we write another analog write. Use the same function, analog write, and then put in the next one, which is blue pin. We call the blue pin function, the blue pin variable. and then the other parameter will now be blue value. Then lastly, we use analog white again. So take note, the reason why you're saying white is because you want to write to the analog pin or that pin you're using. So when you say digital write, we're working with the digital, writing to a digital pin. When you use analog write, writing to an analog pin. And digital pins are from pin 0 to pin 13. So I told you that those PWM pin act like analog pins, so you can use some analog functions for those PWM pins. So that's why we're using the analog write function for it. So lastly, we'll now say green pin. Then we will use the green value as the second parameter. Okay, so we're done with this function. So now to make our code make sense, inside our void loop, what I just need to do now, I'll simply call the name of this function we just created, which is RGB color. So I just say RGB underscore. So make sure the same way you typed it, that's the same way you type in here too. You open the brackets, close the brackets, and here, so we'll put the color intensity for the red, blue, and green because our function has three parameters: red value, blue value, and green value. So I have to put that in. So I will say, let's say I used 255, 255, 255. Okay, so that is the first one. So end with a semicolon. So this I think will show either white or black, something like that. So this will be either white or black. So let's just test run this to see if it works properly. Then I'm going to explain my code properly. So click on start simulation. Oh, giving me expected error. Oh, okay, I didn't put my semicolon. So if you click on start simulation, so you just add the semicolon to make it work properly. So click on start simulation. So it's starting. So if you see my LED is just showing white. So because I use the highest for all of them. So the different intensity you'll be using, different colors you'll be creating. So let's create more colors. So go back to my code and then I add a delay here. Let's say delay. Let's use 1000. Let me just 5. Let's see delay for 1 second. Okay, so let me show you other colors you can use. Okay, so we'll come over here and then let's use color intensity for yellow. So we just call our functions again, RGB underscore color. Then you open, close the bracket, close the statement semicolon, and then let's put in the color combination for it. So we say 255, 255, 0. So that we create yellow. So let's add a delay to that. Let's use the delay function to delay, so to stay on for that color for 1 second. So now let's create another color. So we say call the function RGB underscore color, and then open, close the brackets, close the statement semicolon, and then let's put in the color combination for a different color. So next, we use a color combination for magenta, which will be 255, 0, 255. So just make sure that note that the first one, which is red, the value of red is 255, and then the value of blue is 0. I mean, so nothing. And then the value of green is 255. So the mixture of this intensity will create magenta. So add a delay. Okay, we use a delay. We use a 1000 millisecond or 1 second. Okay, then lastly, we call the RGB function again. RGB underscore color. Open close brackets. Close the statement semicolon. Always close statement semicolon as an habit because it will give you issues. So RGB, type that wrongly. RGB, yeah. So here we'll be using black. So to use black, you just 0, 0. Black is a negative value. So 0, 0, 0. So that will be for black. Then just add a delay. 1000 millisecond. All right, we're done with the code. Now let's click on start simulation. But before that, inside the function, like I said before, when we call in this function name, we have to put in the parameters. And what is one inside this function is a built-in function called analog write. It writes directly to the analog pin. The first argument needed for the analog write function is the Arduino pin. So instead of we using the Arduino pin, we just simply call the variables we created at the top, which is red pin, and red pin has a value of 3. So we just call the function red pin and then add a comma. So the next argument we use for the analog write function is the red value. So the red value we fetch that data from the function we created at the top, red value. So whatever value we add to it is going to add here automatically. So now if you come up here on our variable, on our loop where we call the function, you see we passed in the color intensity inside there, or the data we passed inside this function will now be used by this same analog write. Okay, so if you get me, well, this value we passed on this function we called. So for instance, say 255, 255, 255. So this same value passed will be used inside this analog write function. So whenever we use red value, blue value, and green value, these are the values that will also be used here. So it will enable the function write directly to the pin. Okay, so that's all. So now I hope you understand what I explained. If you don't, just rewatch the videos, or you can just reach me out if you have any issues. So you click on start simulation, click your code to move everything back. So if you observe, showing white, green, it didn't show black, you just showed nothing. Okay, in black has its own color combination, it's not 0, 0, 0. Okay, so you see different colors changing magenta, white, yellow, whatever. So you can add more colors, You can just Google different color intensity online using RGB format. There are different formats, there's HRF, but use RGB format. You see different color combinations for different colors. And you can just put that inside your function, and then you can display whatever color you want. So that's all for this class. See you in the next class.